Hello everyone, so today we are going to start with a new playlist that is cryptography. We call it as Introduction to Cryptography. And first I'm going to introduce the goals of cryptography and what are the classifications of cryptography and what are the different type of applications of cryptography, and then what are the security notions involved here. Okay, so I'll start with the first chapter, that is called Overview of Cryptography. Overview of Cryptography. Yeah. So cryptography is defined to be an art and science of secret writing. If you come to the word cryptography, it is made up of two Greek words, crypto and graphy. This crypto, it is made up of Greek word cryptos, which means hidden, and graphy means it is from graphio. These are the Greek words. Graphio, which means writing. So formally, cryptography is the study of secure designs required for the protection of sensitive communication. So if you want to compute, so it's just for a simple example. Suppose there are two person, say Alice and Bob. They would like to send Alice want to send a message to Bob. Okay, you want to send a message to Bob. The thing is that their communication, this message should not be revealed by any other guy. Say adversary, there is one more guy whose name is adversary. He should not able to know this message, so I have to encrypt the message. So instead of directly sending the message, I am going to encrypt the message, and this encryption of message cannot be decrypted by this adversary. Okay, so we'll come to that, what is happening in this cryptography. Okay, let me just define what is the definition of cryptography. What is the definition of crypto system? Or simply, if you say, actually cryptography deals with the means and methods of data conversion in a secure form so that data cannot be used by unauthorized person. As I told you, I was having two people, Alice and Bob. Alice want to send some message to Bob, but she don't want to reveal this message to any third party, so it should, the communication should be secured. So what she does, she send the encrypted data to the Bob, and the key for the decryption of that encrypted data will be available to the Bob. So once Bob received, he will apply the key and get the message. So basically, a crypto system is a five tuple. A crypto system is five tuple. We call it as P, C, K, ED. That means suppose you want to form a crypto system, you have to create this pi tuple satisfying the following conditions. Satisfying the following conditions. First, P is a finite set of possible plain text. P is a finite set of possible plain text. Okay. C is A finite set of possible ciphertext. Finite set of possible ciphertext. Ciphertext is encrypted data. Plain text which I have encrypted, that is called ciphertext. K is the key space. K is the key space. Again, it is finite set of possible keys. Finite set of possible keys. Okay. Fourth thing is, for each small k in key space k, if you take any key, there is an encryption rule. There is an encryption rule, or you can call it as rule function. We call it as ek, which depends on this key. Ek belongs to e. Okay, ek is a function taking the message from plain text and giving it to the ciphertext, the space of ciphertext. And decryption rule which is from the set D and DK. It's taking the ciphertext and it will give you the plain text. Okay, such that for any plain text, x belongs to p, you're having y is equal to ek of x is the corresponding ciphertext. Okay, and if you decrypt this ciphertext, if you apply dk ek of x, you will get back your x. That means this dk and ek are inverse of each other. Okay, it is something like if you integrate, if you differentiate an integration, you'll get back your function. They are inverse of each other. It is similar to that. So what this says, suppose I'm having a plain text x which I want to encrypt. I'll apply this encryption function. What does it do? It will convert your message x into y. I am able to convert it as y. This y is your unclear message. We call it as ciphertext. It is non-meaningful form of the plain text. So this is why, by looking at this, why you cannot get the value of x. You cannot guess, or you won't able to. Only if you are having the key, then you can create this decryption function, this dk, which takes the ciphertext and it will give the plain text. Again, it depends on your key. Okay, so this is what a crypto system means. You will be having this is phi tuple, this is plain text space p, this is ciphertext space, this is key space, this is encryption functions, this is decryption functions. For every key there will be an encryption and decryption functions. Okay, yeah. So in simple form, if I say, suppose this is Alice having, this is Bob. Okay, he want to send a message, and what he does, he log this message M Suppose both are having same key k. He also know the key. He also know the key. Okay. This is the message M. He is sending this message M to him. This message is actually encrypted form, so it will be have some value, something like dollar, percentage, key, M, and exclamation mark, and something question marks, E, Z. So this is something like of this form. So by looking these things, you cannot get the message. The message I have written hello world. So once this cipher text is received by this guy, what he is going to do? He is going to apply its decryption function. Then this encryption will break away. He will get the message if we apply the decryption function. Okay, this was the message. He applied encryption of this. He got this encrypted message. Okay, so that's perfect. Now the thing is, what is the goals of cryptography? Why do we want to go? What are the things it can give? Goals of cryptography. So the goals of cryptography is actually abbreviated as PAIN. PAIN. Now what is this PAIN? I'll tell one by one. So first P is for privacy. Privacy, or you call it as confidentiality. What do you mean by this? Privacy, confidentiality. It means that no one except the authorized users, say sender and receiver, should be able to see or detect the message communicated between them. Suppose there is sender and receiver, correct? If they want to communicate something, no one else should able to decrypt that message. Suppose this is the message they are transferring, no one else should get to know about the message M. Correct? This is the privacy. So his message, the message whatever he is sending, should not be revealed to other guy. Okay. So secrecy is a term synonyms to privacy, and so you may call it as secrecy also. Okay. So if you say that privacy actually refers to an individual's right to control access to their personal information, where confidentiality refers to how private information provided by the individual will be protected from the release. So there is a simple difference between privacy and confidentiality. So privacy is your right to control access to your data. Okay, and what is confidentiality? Confidentiality, how private information will be protected, how private data will be protected. So in short, we call it as secrecy. Okay, so this is the first goal of your cryptography. That means your crypto system should have the privacy. That means nobody else should get to know about this. Next is A, that is authentication. Okay, what do you mean by authentication? So authentication is a service related to identification. See, the receiver should be able to validate the actual source. suppose as I told you, I'm having Alice, I'm having Bob. If Alice is sending a message to Bob, after receiving the message, Bob should able to identify that this message is sent by Alice. It is not sent by someone else. Correct? It is not sent by someone. So by receiving the message, he should. That is what authentication means. After receiving the message, he should able to authenticate the source of the message. That is called authentication. It is yeah, as I told you, it is a service related to identification. The receiver should be able to validate the actual source or origin from where the message has been transmitted. In short, the two parties involved in the communication should be able to identify each other. Two party involved in a communication should be able to identify each other. Okay, so this is your authentication. So there are actually two type of authentication you can talk here. Correct. First is the authentication of server, and say, or you can say user authentication, or second is the message authentication. See, after receiving the message, I should authenticate whether it is a valid message or not. That is called entity authentication. Yeah, that is called your whether the message has not been altered or something. Correct? And the source data origin authentication means whether the message is received from Alice or not. So entity or user authentication and data origin or authentication. There are two authentication which we are going to see here. First is user authentication. Second is data origin authentication. Okay. So this was your A. Next is integrity. What is integrity? See, during communication, no one should be able to modify the message. No one should be able to modify or alter or change or delete the message. See, as I told you, suppose I'm sending a message, no one in between should able to alter the message or modify, change or delete the message. That is called integrity. Your message should not be changed. So next is non-repudiation. What do you mean by non-repudiation? See, the actual participants, sender and receiver, should not be able to deny their involvement in the communication. See, there should not be that Alice said that I have not sent any message, or Bob said that I don't know, I am not communicating with you, or something like that. That is non-repudiation. The actual participants, say sender and receiver, should not be able to deny their involvement in the communication. Okay, so this is what your pen. One more thing is access control. Access control. What do you mean by access control? Only the legitimate users. Only the legitimate users are granted access to the resources or information. Correct. So these are the goals of cryptography. First is authentication. You should be able to authenticate the message or the entity who had sent. Next is integrity. Your data should not be altered or modified. Non-repudiations. The actual participant should not able to deny that they are not involved in the communication. Access control. Only the legitimate users are granted access to the resources or information. Yeah, and different cryptographic primitives have been devised to achieve these goals. So these are the goals, and if you want to achieve these goals, you have to use some cryptographic techniques. So for privacy, encryption scheme is enough. They told you privacy means what? Your data should not be revealed to any other guy. So in that case, we are going to use encryption scheme. So this is our help here. Whereas in the case of authentication, see entity authentication, if you want to do, then you can use digital signature. We'll be learning these techniques. What are they? Integrity can be achieved by hash function. Non-repudiation can be again achieved by digital signature, or that is one more called is the undeniable signature. So I'll call it as digital signature or undeniable signature. Again, that is a form of digital signature only. We will precisely actually discuss about these things. What are those? Okay. Okay, so finally now next part is, let us see classification of the crypto system. What are different crypto system? Okay, maybe I'll do it in the next class. We'll start with classification of crypto system. Thank you so much.